Okay, we've got a couple more items to look at to prevent any freezing in our piping network. And the general concepts are going to be in the pumping uphill, pumping downhill, or pumping on the same level to the Oscars. In all three of these, what we're really looking at on the underlying principle is to allow the water to drain out between cycles, especially drain out where it's going to be close to the surface of the ground. If the water's not there, it can't freeze. So that's kind of what we're gonna go by here. So the first one is really pretty easy, pumping uphill. You can see our tanks are here. We put our headworks on top of the tanks for thermal protection, and then we're pumping up a gradual slope up, and of course it may be an extreme slope up, but it's all going up. So what'll happen when the pump shuts off, any water that's in this pipe, because of the design of the manifold and so forth, or the headworks, I should say, water will be able to drain back into our tanks, which is what we want to do. So that one's pretty easy, pretty straightforward. And what we're looking at on the headworks is we've got on the outlet side, we got the supply going up to the coils. We got our return, our flush line coming back from the coils. And then we got this middle port that's the two tank. And that's where all the flush water from flushing the coils and flushing the disc filter and for draining the pipes would go follow this pipe in and around to our 4-inch 4x1T that we have installed between the two tanks. So this relationship, we'll come back to it, is going to be very important in knowing how or when the system will drain. So if we're pumping downhill, typically, it's going to drain no problem down to the coils. We can put this pipe pretty much as deep as we want. The only problem is that this last little juncture here, you can see where I put the circle. When the pump shuts off, it won't drain any more than the elevation of this coil. And that is if we draw a line going back up to here, we're going to have about this much of the pipe full of water. Now we're not going to freeze this over here, but we got a pretty good chance of freezing it here. So what we're going to need to do is to change that dynamic so that we're not trapping the water, we're allowing it to drain out. So I'm going to flip the drawing around on you a little bit here, come from the other direction. So instead of coming all the way down under the Oscar and up, what we're going to do is to make sure that that supply and flush line in red does not go below the top of the coil. So here I've got a blue line that kind of just shows the elevation there. So as we're digging down in our original trench, we know that there's a certain point that we have to stop going down, and we have to kind of follow a slope to the manifold, both supply and flush. And then we will need to backfill the bottom of the pipe because it's going to be sticking out of the ground, and then cover it with some soil for thermal protection. So pumping downhill is going to require a little bit more nuance in doing the backfill and the last connection between the supply and flush line, supply and flush line and the coils. And this is it right here. Okay. So overall, what it would look like, similar to pumping uphill, it's just that we've got it reversed. We are going to pump downhill. Again, we're coming off the headworks. This has a fairly positive slope. And as long as this generally has a positive slope, we're going to be just fine. It's key that we make sure that this portion here especially will drain out and maybe back up into here in this trench a little bit. Drains out between cycles. And if we do, we're going to be fine. Not a problem. Now, the tough site is going to be on the level site. The Idaho code says that the top of our tanks, pump tank and septic tank, have to be 2 feet above the winter water table. If you take also the requirement for the Oscar, we can have the bottom of the Oscar within 12 inches, just greater than 12 inches to the water table. So I got a blue, black, and red line here. And my black line is my original grade. We can put the Oscar at that original grade. But because of our winter water check, I have to have this tank sticking out of the ground a little bit. So I've drawn this blue line to show you the elevation of the flush line, or the two tank line coming out of the headworks box. You can see the bottom of the Oscar is below that invert. So potentially, if we have our pipes coming up here to our supply and flush manifolds, we're going to have a significant amount of that pipe full of water that is above the surface of the ground. But if we look at our red line here, this is the elevation, relative elevation, of the 1-inch port on this 4x1T if we rotate that port 90 degrees. So let me do that real quick. This is from the top view. If I rotate that elbow, or excuse me, that T, that brings that 1-inch connection down from the top of the tank to here. It's a differential of about 12 inches. So I can take and move this headworks from the top of the tank, move it off the tank, make sure it's on bearing ground. I don't want to put it in the annular space of the hole where it's going to settle. But if I move that off the tank, that puts this whole apparatus here about a foot deeper in the ground. So not only does it get more frost protection, just being deeper in the ground, but it also lowers our two tank port here, which will allow for more water to drain in on other aspects, like on the Oscar. So to take a look, show you what that looks like. Here we've got the same relative elevations between the blue, black, and the red line. Tank still sticking out of the ground, Oscar still on top of the ground. But in this case, we've got our headworks box off the side of the tank. And it's down lower. I'm only showing it maybe about 6 inches lower, but it's about a foot lower. And so now we can drain more of this water instead of having the water line up here in the sand. The water line is going to be pretty close to this red line. So here isn't too deep, but if we were to dig this trench deeper and actually then submerge that pipe as it went underwater and then came up to the headworks box, we'd have, say, 3 feet of soil over the pipe. We'd get that line down deeper in the soil where it would be warmer, and consequently we wouldn't be freezing anything. So it's a lot nuanced, but this is the way in those flat sites that we're gonna have to deal with this with those shallow winter water tables. I hope that makes sense.